Hello dear students, this is your Jagan sir from Physics with Jagan sir Academy. Now we are going to discuss some important concepts which is continuation from the last class, and we are going to discuss what is unit vector, what is position vector, what are the direction cosines representation, and all these things we are preparing or practicing now. First of all, what is unit vector? See, in all the cases, a vector means it is not necessary to have a certain magnitude, and some vectors are basically useful for the representation of a particular direction. Here, suppose, let us consider let us consider a particular vector which is representing only direction, it does not represent any magnitude. That means before that I will give you an example. Suppose it is a coordinate system. We are considering, let us assume it is a coordinate system. In this coordinate system, suppose here is a point, here is a point. I can say it is having 3, 6, 8 as its coordinates. Then we don't know really whether 3 is representing in the x-axis or y-axis or z-axis. Similarly, 6 is representing in the x-axis or y-axis or z-axis, as well as 8 is representing in the x-axis or y-axis or z-axis properly. For that purpose, what we are doing is we are saying this is as the coordinates of this point. This point we can say in terms of a vector as r is equal to 3i 6j 8k 8k. Here I, j, k, these are unit vectors. These unit vectors helps us to tell in which direction this magnitude is representing. That means if it is representing with I, we can say that it is representing along x-axis. If it is j, then we can say that it is representing along 6 is representing along y-axis, x-axis, y-axis, z-axis. Similarly, 8 if I am representing along with the k like this, we can represent 8 is representing in the direction of z-axis. So here I cap, this is hat r cap, is representing orthogonal unit vector which is specially for x-axis. J is specially for y-axis. K is specially for y-axis. Along with this I, j, k, if I am adding or if I am representing some magnitude, this says that that particular magnitudes are particularly represent in one particular direction. So this is the application of unit vector. And next point is the magnitude of unit vector is the magnitude of unit vector is 1. The magnitude of unit vector is 1. Here I, j, k. Originally I cap, j cap, k cap. They have magnitude as 1. That's why they would not change originality of the vector, but they represent in which direction this magnitude is present. Clear? Right? Next, let us suppose a vector A. Let us have a vector A. Now AXI, AYJ, AZK, if it is the relation. Now, can I write a unit vector for this particular vector? Yes, we can write. That is A hat is equal to A vector by its magnitude. A vector by its magnitude. Now, here A vector means AXI plus AYJ plus AZK by a magnitude. Magnitude means under root of ax square, ay square, az square. This is representation of a unit vector. Okay, then next part, vector addition. Addition of vector by means of components. Addition of vector by means of components. Let us say the next case. addition of vectors by means of components. Right. See here, let us assume this is x-axis, this is y-axis. Over this x-axis and y-axis, here a vector is present. Let us name it as A. Name it as A. This vector will have its position on x-axis as ax, its position on y-axis as ay. Okay, now A is a vector. It is ax, which is representing I cap means along the x-axis. Then a y j. This is ay representing on the y-axis. Similarly, if I am adding one more vector to this vector, b vector, this b vector will have again two components. This becomes bx, this becomes by. So again I can write b is equals to bxi plus byj. Okay, now see here, next point is, suppose I am adding these two vectors. Now this will be the resultant. That resultant I can write as, that resultant I can write as r is equals to, see, from here to here, the point I am representing with rx, and total with respect to origin line I am representing r by, and this is originally a plus b, r is equal to. So can I write it as axi plus ayj plus a, sorry, bxi plus byj. That means ax plus bx of I is equals to ay plus byj. Okay, now according to diagram, rx is equals to ax plus this one is bx according to diagram. So can I say this is equals to rxi? Similarly, from diagram we can say ry is equals to, this one is ay and this is by. So ry is equals to ay plus byj. This is r vector, r resultant vector. So resultant vector magnitude is rx square plus ry square. That means r under root of, you can also write it as ax plus bx square plus ay plus by square. This is what the addition of the two vectors resultant value. Now the next point is, see here, this resultant suppose making an angle alpha. Let us assume this resultant is making an angle alpha. Then tan alpha is equal to opposite by adjacent. So we can write here directly tan alpha is equal to ry by rx. That means tan alpha is equal to ay plus by ax plus bx. This is how we are adding two vectors. Clear? Then next one is, Right. Let us see an example over the addition of two vectors. Given A is equals to 2i minus j plus 3k and B is equals to 3i minus 2j minus 2k. And they are asking us to find the unit vector of a plus b and a minus b. First of all, what is the value of a plus b? A plus b becomes 5i minus 3j plus k. Okay. Now, unit vector, let us assume this is r, then r unit vector is equals to r vector by r magnitude. That means 5i minus 3j plus k by under root of 5 square plus 3 square plus 1 square. Actually, here plus of minus 3 whole square. So, automatically that is directly equals to plus 3 square only. Then the unit vector is 5i minus 3j plus k by 9 or 25 plus 10, which is equals to 35. That means r cap 5i minus 3j plus k by root 35. Here I found answer for a plus b case, and I am giving you as homework for a minus b case. A minus b case I am giving you as a homework. Next part, direction cosines. Before we are going to discuss direction cosines, I would like to tell you position vector. Position vector. See here, let us assume it is a point. This point P is at a position with respect to origin R, at the position R. Now along the y-axis it is having R, by along the x-axis it is having R x. Now orthogonal unit vector I, orthogonal unit vector j cap. Now R is equals to, we can say R xi plus R by j. This is the position of the vector representing by using orthogonal unit vectors with the magnitude on x-axis and y-axis simultaneously. Now, respectively, then next part is, see here, if it is making an angle theta here, can I write now cos theta is equals to r x by r adjacent by hypotenuse. Now, sin theta is equals to ry by r, opposite by hypotenuse. Next point, similarly we can say it is rx is equals to r cos theta, ry is equals to r sin theta. And again see here, the magnitude of this vector is under root of rx square plus ry square. Okay, rx square plus ry square. Similarly, if I am squaring and adding these two, rx square plus ry square is equals to r square sin square theta plus cos square theta. And we know from trigonometry, sin square theta plus cos square theta is equals to 1. So obviously we are getting the same answer for the position vector magnitude. Magnitude of the position vector is becomes r under root. Now this one and this one will be same. And here students has to remember one most important point. It is, see here, suppose if it is the case, now we can say cos theta is equals to rx by r, right? That is, theta is lying between adjacent one and the hypotenuse. Suppose you have a situation that is like this, r by, here angle theta is present. Now still you need to write cos theta is equals to, now the the angle is made with this one and this one. That's why you have to write here r by r. Don't try to remember like always x-axis value is present here. It is not the case. You have to consider through which to which the theta is present, and the theta is present with the resultant and the line with which it is made. Then that point we have to consider on the numerator. Clear? Then next one is, now we are going to see direction cosines. Direction cosines. Now direction cosines means, see, suppose we have a position vector here, point P, with the value of Rx, Ry, Rz is its coordinates. Now this position vector R, right? So can I say now R is equals to Rx square plus Ry square plus Rz square. Just now we have seen how to write the magnitude of the vector. So we can write like this. Clear? Now next point, see, if it is making an angle alpha here, let us assume if it is making an angle alpha here, then cos alpha is equals to, we know this is Rx, we know this is Ry, and this is Rz. Okay, that means the point is having on x-axis Rx as its value, on y-axis Ry, and actually it is out of the board, z-axis is at the out of the board, but we could not represent that on the two-dimensional board. That's why I am representing like this. On the direction of out of the board, the z point is like at this point, so the point is like this. Okay, the point is like this, and this point is, now angle between these two is beta, and this point is with respect to this making an angle gamma. Let us assume making an angle gamma, right? Now cos alpha is equals to Rx by R. Similarly, can I say cos beta is equals to, it is making angle with this line, this is the position resultant, so Ry by R. Similarly, can I write cos gamma is equals to Rz by R. Okay, now by squaring this one, cos square alpha, cos square beta, cos square gamma is equal to Rx square by R square, Ry square by R square, Rz square by R square. Now Rx square plus Ry square plus Rz square by R square. This is equals to R square by R square, which is 1. That is cos square alpha plus cos square beta plus cos square gamma is equals to 1. Is equals to 1. This is the condition for direction cosines, and this is, let us assume, L, M, N, and these are known as direction cosines. Direction cosines. Right? Then this is the final condition, and these are known as direction cosines. Clear? Now next one is, let us go through with one example over this concept. Right, a bird moves with a velocity v is equal to 20 meter per second in a direction making an angle of 60 degrees with the eastern line. See here, let us assume this is eastern line, this is northern line, right? And 60 degrees. Suppose it is making with eastern line 60 degrees and 60 degrees with the vertically upward. Let us assume, see, this is x-axis, this is north, this is east direction, this is north direction, this is upward direction. This upward direction is this one. Chalo. Otherwise, we can represent like this. Upward direction is like this, and it is making 60 degrees with the upward direction also. 60 degrees with the upward direction. See, east direction, north direction, east direction, north direction, this upward direction, upward, as it is two-dimensional body, we could not represent like this. So upward, again it is making an angle 60 degrees. If the eastern direction is taken as x-axis, very good. Northern direction as y-axis, very good. We correctly representing upward direction z-axis. So upward direction we are considering as z-axis. Then represents a velocity vector in rectangular form. Rectangular form means r is equals to r xi plus r by j plus r z k. This is what is rectangular form. Now see here, according to our concept, this is alpha, this is beta gamma, because upward direction we are considering gamma, and northward is beta, right? Now by using cos square alpha plus cos square beta plus cos square gamma is equals to 1, that is cos square 60 plus cos square beta plus cos square 60 is equals to 1. That means cos 60 is equals to 1 by 2 whole square plus cos square beta 1 by 2 whole square is equals to 1 by 4 2 times plus cos square beta is equals to 1. So cos square beta is equals to 1 by 2, then cos square beta is equals to 1 by 2, then cos beta is equals to 1 by root 2, that is beta is equals to 45 degrees. 45 degrees. And they are asking us v in rectangular vector form, that is vxi v by j vz k. Now what is vx here? V cos, with respect to x axis it is making an angle of plus v angle 45 degrees plus, sorry, j plus k with respect to north direction 60 degrees, and given its magnitude as 20. So 20 cos 60 is 1 by 2 I root 2 j plus 20 1 by 2 k. Okay, that means 10 I plus j plus 10 k. This is the velocity of the. I hope this will be the last. This is our second class on vectors. We had completed success. You can message me in our